Hello everyone and welcome to the Data Journey YouTube channel. So as a data scientist, you probably may feel a bit lost about all the predictive models that are out there. So in this video, we are going to see arguably 6 of the most important models that you need to know to be an effective data scientist. Although this is an opinionated version of machine learning and predictive modeling, I think that these models that we are going to see here are the base for most of the models out there, and by understanding the inner workings of these models, you'll be able to understand how a lot of machine learning models work. And also, we are just going to see supervised learning models here and not unsupervised learning, particularly because I think that when you start, supervised is the most easy way to go. I'll do another version of this video, but for unsupervised learning models. So let's start. The first model is, of course, the linear regression. So the linear regression is around since, 200 years ago. In this model, what we want to do is to draw a line that predicts a continuous variable based on other features. So linear regression is then one of the oldest models that we have in terms of machine learning, and it's a staple in the econometric area as well. So learning this model will give you a good intuition behind solving regression problems, which are the problems when we want to predict a continuous variable, and also will help you visualize how we can predict data based on features. There are also other benefits on learning linear regression, because you may learn two methods to be able to achieve a good performance. The closed form solution, that is basically a formula where you can get the best weight for the variables, but you can also look at it as a gradient descent problem where you tweak the weights of the model so that your line best fits the data that you have. The cool thing about linear regression is that you can visualize it, particularly if you are only using one variable to predict the target. Also, linear regression is one of the most interpretable models in machine learning, with the downside of having too many assumptions to work with that may end up ruining your predictions. Nevertheless, the fact that it's interpretable, easy to visualize, and fairly easy to understand makes it a staple to learn when you start to work with machine learning. Now, the second model that we will see is called the logistic regression. And this model is basically a way to generalize linear regression for classification problems. And mostly you'll learn binary logistic regression first. Although it has regression in its name, and logistic as well, it doesn't take care of regression problems, and it's not only applied to logistics industry as well. Although the name is a bit confusing, it's a very good one to understand how we can work with the other most common types of problems in machine learning, in this case classification problems. Logistic regression is very good because you will be able to visualize how to split classes in a plane, so in a dimensional plane. And having a first glance at classification and multi-classification problems with logistic regression will be fairly easy to understand using this model. Another good thing of logistic regression is that you'll learn your first activation function as well that will be very useful for neural networks. In this case, the sigmoid function that will transform your output between 0 and 1. Understanding the mechanism of logistic regression will give you a way to abstract this thought of having an outcome and then passing it to another function. Also, with the logistic regression, you'll take a look at the log-loss function, which is one of the most famous functions to build models on classification problems. An example of problems that logistic regression solves, imagining if you have a bank account, checking if a transaction in the bank account is fraudulent or not, understanding if a customer will leave your bank or service in the future, and this is called the problem of customer churn, or also classifying loans, for example, in their probability of default. These examples that I gave you are from the banking industry, but there are many more industries where these types of models are used. Everything where you have a class target, where you allocate your instances to, will be a fit for logistic regression. So logistic and linear regression are basically two linear models. They are not able to deal with complex patterns, but there's a base type of model that's very good to deal with those complex nonlinear patterns, and this is called decision tree. So decision tree is the first nonlinear algorithm that I recommend you to study. So it's fairly simple and explainable, and it's based on if-else rules. Studying the decision tree will give you a good grasp on nonlinear algorithms. Also, the decision tree is the building block for other models that we'll see next. such as the random forest or the extreme gradient boosting. The cool part is that decision trees can be applied to regression and classification with minimum differences between the two. The rationale behind choosing the best variables for the outcome of your model is roughly the same, although you just have to switch the criteria if you are dealing with classification or regression. And here decision trees will also be very important because they will give you probably the first contact with hyperparameters. These parameters are parameters given by the data scientist and not really learned by the algorithm. Learning a decision tree will be extremely useful to deal with this concept as well. A downside of decision trees is that they tend to overfit. By studying the nitty-gritty of decision trees, you'll understand what overfit is and how overfit works, giving you more confidence in going for other models. Okay, so as I've said, decision trees are very prone to overfit. But there are other types of models based on decision trees that are not. If a decision tree is a dictatorship, the next model is the democracy version of it. So the random forest is a very simple concept. It picks up a lot of decision trees and tries to average the values or the outcome of those individual decision trees to make better decisions. When you study random forest, you are really studying how to ensemble different models into one single decision. Random forests are extremely powerful, and learning them will give you that grasp of how overfit and underfit work and how we can use a base model such as a decision tree to get to better predictions by combining the opinion of different individual models. Finally, there's a model that has been becoming the de facto model to solve tabular data problems. So problems when you have tabular data, not computer vision or natural language processing. And these are called the boosting models. So if random forests are called the bagging models, boosting models are very interesting because they work on the errors made by the previous learners to find patterns that are more robust and generalize better. Two of the most famous boosting model implementations are extreme gradient boost and light gradient boost. Both of them are available off the bat in Python. So this stream of thought regarding machine learning models gained traction after a paper called Weak Learners and Hypothesis Testing. Boosting models may be an excellent solution for the overall bias-variance trade-off that models suffer, as we've seen overfit and underfit. So studying boosting models will be extremely cool because it will help you to understand how this type of technique of working on weak learners will give you better results in the end for your model. And finally we get to the last model, which is of course the neural network. I would advise to start simple before jumping into deep learning architectures, but of course we can't ignore neural networks in the machine learning world today. Today, considered the holy grail of predictive models, artificial neural networks are currently one of the best models to find these non-linear patterns in data and really find the complex relationships between independent and dependent variables. Learning them will get you exposed to different concepts such as activation function, backpropagation, and the fact that we can stack layers inside neural networks. This concept should also give you a good foundation to study deep learning models. Additionally, neural networks have a ton of different flavors when it comes to their architecture. First, you should start the most basic ones, such as a feed-forward neural network with some neurons in the inner layer, but then you can jump to recurrent neural networks, convolutional neural networks, or even the attention mechanism that is used today in generative pre-trained transformers, the famous model behind ChatGPT. And so, that's basically it. I hope you've enjoyed this video. Feel free to join me on Udemy on my data science, Python and R courses. Also, if you've enjoyed this content, make sure you subscribe to the Data Journey channel and stay tuned for next videos on data science and machine learning. I'll see you in the next video.